Okay. Assalamualaikum. My name is Ahmad Daniel bin Muhammad Zuki and I will be the first presenter to present and discuss about our mini project. As you can see on the screen, the title chosen for this project is an automated speed controller for fans and coolers. So I will start the presentation by covering the introduction and the first part of methodology. Next presenter, which is Hana Rais, will continue with methodology, and the last presenter, Muhammad Hazi Hakimi, will presenting on discussion, conclusion and the cost of the project. Okay, so first of all, let me start by giving you an overview of this project. As you know, fans or coolers are commonly used in many different settings, from residential homes to commercial buildings and even in industrial applications. While fans are an effective way to cool down a space or circulate air, they can also consume a lot of energy if they are running at a higher speed than necessary. Hence, our automated speed controller for fans and coolers are designed to address this issue. By using temperature sensor and algorithms, the controller can detect the temperature in a room or space and adjust the fan speed accordingly. This means that the fan will only operate at the necessary speed to maintain a comfortable temperature, saving energy and could improve the gadget use to make our life easier. In order to perform the task, I present to you a simple block diagram of our project. Based on the block diagram, we are using PIC18 microcontroller as the main component. The PIC microcontroller will be used to store and process the source code from the MPLAB software. It will execute the action required to control this fan speed using fan DC motor by receiving input from the temperature sensor, and lastly the temperature of fan speed should be displayed on LCD. And that's all from me. I will pass the presentation to the next presenter, Hana Rais. Thank you.
Assalamualaikum and very good days. Today I would like to share to you the methodology of our project. I will explain to you the part components in this project. So the first one is we use the PIC18 microcontroller. Basically, we know the microcontroller is a computer control system that is equipped with numerous electronic circuits and that can read a written instruction and transform them into the electrical impulse. The microcontroller will go through this instruction one at a time and carry them out. Next, we have temperature sensor LM35. The temperature sensor chosen for the design is the popular LM35IC temperature sensor as shown in figure below. LM35 is a 3-terminal integrated circuit and it's rated to operate from negative 55 degrees centigrade to 150 degrees centigrade with a linear scale factor of plus 10 degrees Celsius. And next we got a fan or DC motor. Fan or DC motor will start to rotate when the temperature sensor senses the surrounding temperature. The microcontroller applied in this system has an integrated PWM module that is used to regulate the duty cycle to control the fan speed. Fan speed is controlled by automatically varying duty cycle in accordance with temperature sensor inputs. And the last one, we use a liquid crystal display, which is LCD. So LCD screen is an electronic display module and finds a wide range of application. A 16/2 LCD display is a very basic module and commonly used in various devices and circuits. So this is our operational flowchart. So we got start button, and then the LM35 temperature sensor will detect the surrounding temperature, and next the fan DC motor will turn on and the speed based on a temperature detected. So we got a three stage here. If temperature 25 degrees, we got a slow speed, and then when the temperature turns to 28 degrees, it is medium, and last one when temperatures up to 33 degrees Celsius, we got a fast fan speed. Next, the LM016 LCD will display the temperature from temperature sensor and the speed of fan motor, DC motor. Then we got and this is our circuit, and then so this is a result for the first point. The display shows temperature high when the temperature sensor detects more than 30 degrees Celsius, and temperature low when it detects less than 30 degrees Celsius. For the next point, the fan operates dependently on the MCU. It is given instruction based on the temperature sensor LM35. For the last point, the automatic fan works without human effort as long as it's powered up. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Asyik Kini bin Kifli. Number matrix 2120600436. Okay, for discussion of our project. The purpose of this project was developed a program and designed to a circuit to make fan or cooler that can be controlled automatically based on the temperature. So, bila temperature tinggi, kipas ni akan bergerak dengan lebih laju, dan bila temperature rendah, kipas ni mungkin akan berhenti dan mungkin akan lebih perlahan. To make it success, the program from the source code should be written correctly and it must be transferred to the PIC 18F4580 microcontroller yang kita selalu guna kat dalam lab and apa kita belajar dekat dalam kelas lama ni. Input software to proceed the next process, which is circuit simulation. There are a few components that are important in designing circuits such as temperature sensor, fans, DC motor, LCD, and all of these components should be taken seriously in terms of port pin connection with PIC 184580 added in source code or circuit. So, apa yang kita guna ni, kita masukkan ke dalam pin yang betul dan port yang betul. Jadi, kita masukkan hex file ke dalam PIC 18F4580. Jadi, dengan apa yang kita buat tu, mungkin tak akan ada masalah dengan apa yang kita buat. So, lepas seterusnya, for the conclusion, this mini project elaborates the design and construction of an automatic speed fan cooler control system based on room temperature detection. So, kipas ni, dia bergerak menggunakan sensor yang diletakkan di dalam PIC tersebut. Jadi, kipas ni bergerak bergantung dengan temperature yang ada dalam bilik. Lepas tu, PIC 18F4580 microcontroller had been used in order to control fan speed by using DC fan motor. Dalam projek kami ni, kami menggunakan direct current motor fan. The temperature sensor LM35 was carefully chosen to gauge the room temperature. So, kami pilih temperature sensor M35 ni sebab bagi kami dia ialah yang terbaik untuk ukur dalam temperature bilik. The fan speed in RPM and room temperature was programmed using assembly language in microcontroller and the values should be displayed on LCD. Okay, bila kipas ni berpusing ataupun kipas ni belum berpusing, dekat kipas ni ada satu LCD display. Bila LCD display tu dia akan tunjuk nilai yang ada pada temperature bilik tu sekarang. Moreover, the fan speed will increase automatically if the temperature room is increased. Okay, lagi meningkat suhu bilik, lagi meningkatlah kelajuan kipas itu seterusnya. Okay, this is the cost of the project. Okay, untuk PIC 14F4580, jika kita buat research, harga dia mungkin adalah harga RM25, temperature sensor LM35 harga dalam RM15. Fan DC selalunya dalam harga RM50 ke atas sebab dalam ni menggunakan fan DC yang besar. Liquid crystal display LCD. LCD ni harga dia dalam RM13. Masker liners harga dia mungkin dalam RM20. Total dalam RM123 something macam tu lah. Okay, for the last, the group leader is Hanan Rais bin Abdul Malik, and kami adalah ahli Ahmad Daniel bin Muhammad Mazuki dan saya Muhammad Aziz Hakimi bin Zulkifli. Okay, this is the end of the slideshow. Sekian, terima kasih.